Alright, so the idea to to add fractions that have different denominators will be to unsimplify the fractions, unreduce them, if you will, until you get the same denominator on both. Watch this process. We'll do it a couple different ways. First of all, we'll do it the better than nothing way. Here's one way. It's called the better than nothing way. I could write 1/8, and I could say that's the same thing as 1/8 times 1. Why? Because all I've done here is multiply by 1, and that's the multiplicative identity, and we know nothing happens when you multiply by 1. I could say the same thing about the 5/12. I could say it's the same thing as 5/12 times 1. Again, it's multiplicative identity. Then I could say this is the same thing as 12/12. This is just 1. 12 divided by 12 is 1. We've proven that before. That's the jot theorem, just one theorem. And here I could say this is 5/12 times 8/8. Again, by the just one theorem. Now I can go on and use math, and here this becomes 12/80/96, and this becomes 40/96, and that's by multiplying across theorem. That's how we multiply fractions. We multiply across the top and across the top. And look what we've done here. Now we have 96 and 96 on the denominators. We have a common denominator. That's excellent, because now we can use the ATT. Now we just do add the tops. 12/40/96. This is by ATT. Then you add the tops. That becomes 52/96. And that's by addition table, and yippee-ki-yay. You could reduce that if you want, or if your teacher demands it. But it's not. I mean, that's a different skill. We practice it on another occasion. I'll let you finish that if you like, or leave it like that. That's fine. This process, the key here is going from 1/8. 1/8 turned into 12/96. We unreduced the fraction. We unreduced it. Same thing with 5/12. 5/12 looked pretty reduced. We unreduced it so that we can make the denominators match. And we use this mechanism here, the MID and the jot, to unreduce and make the denominators match. And we got a nice fraction. Okay, that's better than nothing. Another alternative, this is one way to do the problem. Another way, a more professional way, would be to be more cautious here with the things you add. You may not need to go all the way to 96. In fact, there's this notion of the least common multiple, and that involves prime factorizing the numbers. 2 times 2 times 2 times 1 plus 5. I'm not going to write 12. I'm going to write 3 times 2 times 2 times 1, and I did times table and multiplicative identity. Here, if you prime factorize it, you can see exactly what each one is made up of, the blocks. You can see the blocks that each one has. This one has 3 2's. Right? This one has 3 2's. This one has 3 2's. And the other one has 2 2's and a 3. 2 2's and a 3. That one has 2 2's and a 3. If I want them to be the same, what I could do is add a 3 to this one and add a 2 to that one. So check this out. This is what they are now. What I want them to be is, so let me use my visual here. This is what they are now. This one has a 3 and 2 2's, and this one has 2 2's. So I want them to match. Here's one way I can make them match. I add a 3 to this one, and I add a 2 to this one, and now look, now they're going to match. Now they're going to have the same denominator, which is going to be 2 times 2 times 2 times 3. That would be 8 times 3 is 24. I could make them both have a 24, and that would be the most effective, efficient way of doing it without having to multiply by the entire number and getting 96 here. This is what I'm going to shoot for. They should both have 3 2's and a 3. Again, this one started off this way with 3 2's. This one had 2 2's. So in order for them to match, they both need 3 2's. So I added a 2 here. Now look at the 3's. This one has 1 3, this one has no 3. In order for them to match, I supplied 3 here, and now they match. That's the idea we're going to go here. So this 2, I'll convert into 1/2 times 2 times 2. This 2 I'll convert into a 3 times 3. I can do that. It's legal by the jot, just one theorem. And this one, 5/3 times 2 times 2. Whoa. Wow, that one's crazy. 2 times 2, that one times, I need to add a 2 here, 2/2. And now they will both have exactly this on the denominator. This will be 3/2 times 2 times 2 times 3 plus 10/2 times 2 times 2 times 3. This is by multiplying across and a little commutativity law of multiplication, associative law of multiplication, a bunch of things from last chapters. But the beautiful thing here is that now we have common denominator. They both have 2, 2, 2, 3. And so this becomes 3 over 24 plus 10 over 24. This is an optional step if you wanted to just clean it up a little bit. And this becomes, of course, 13 over 24 by adding the tops. So beautiful and elegant. This is the way, the professional way to add fractions. Like I said, I'm going to do it a few different ways. This is better than nothing. Don't even worry about the LCM. Just make the denominators match. Better than nothing. Professional way. Prime factorizing to the prime pieces and supply whatever is missing. Okay? Professional way. And then later on, if you stick around, I'll show you the shortcut. Okay, super shortcut. You're going to love it. By the way, this number right here is called the LCM. Super, super important language here. The LCM between 8 and 12 is equal to 24. Whenever you think about LCM, think about adding fractions. What would you need the least common multiple be so that you have a common denominator? That's beautiful right there. That's how we add fractions the professional way. And that was so fun. Let's do it again. Yeah? How about with this one? So I prime factorize it. Again, this will become 3 times 5. Those are the prime pieces. And I can add a 1 there. I can multiply by 1. Here I can do 5 times 5, and I can always multiply by 1. I broke it up using the times table. I supplied a 1 there using multiplicative identity. Perfectly legal and helpful, because now I'm looking at the prime pieces. What do they have? Well, this one has 2 5s, right? This one has 2 5s. This one over here has a 5 and a 3. 5 and a 3. How can I make them both match? Well, I'm going to try to have them both do this. 2 5s and a 3. That's exactly what I need so that they both have. This is what I want, because that one has 2 5s and this one has 1 3. Then what I should do is, on this one I should add a 5. On this one already had 2 5s. It was missing the 3. 3 over 3. Okay. This one over here had a 3 and a 5 already. It was missing the 5. This one over here had the 2 5s. It was just missing the 3. And now they both have 2 5s and a 3. This is by Jot. And now it's going to work out beautifully. This multiply cross, this becomes 1 over 75. Multiply cross, this becomes 15 over 75 by multiplying across there and a little times table. And now I can add the tops. 1 plus 15 over 75. I just add the tops now. So easy. 16 over 75 by addition table. Beautiful. Professional way to add fractions. Prime factorize. Look at the LCM. Again, the language LCM. The least common multiple between 15 and 25. We noticed it to be 75. Okay. Nice, huh?